We're going to review simplifying higher index radicals. Really quickly, I want to remind you about how we simplify square roots. Remember, a square root is just an index of 2. If I want to simplify a square root such as the square root of 25, I recognize that that is equal to 5 times 5, thus the square root is 5. When I'm trying to simplify a square root such as the square root of 8, that's not a perfect square. But if we break it down into its prime factorization, which is 2 times 2 times 2, we see this pair of 2's, which means I can simplify out from that square root of 8, that factor of 2. I write it out in front of the radical, and this 2, which has no pair to go with it, remains inside the radical, and so my square root of 8 simplifies out to 2 times the square root of 2. When I'm dealing with a cube root like the one we have here, cube root of 24, the process looks very similar in that I'm going to take the number that is inside my radical, 24, and I'm going to, by use of a factor tree, reduce it down to its prime factorization as well. Now, since I'm not looking for square roots, I'm not looking for pairs of factors, but my index here, this index of 3, tells me I'm looking for a factor that occurs 3 times. If I look inside this square root, I see right here that I have 2 to the 3rd power multiplied by itself 3 times 3. Just as I did over here with the square root of 8, when I saw 2 pairs of 2, I could remove them from the radical. I can do the same thing over here with my cube root. I see that I have a triple of 2. That means that factor 2 can be removed from the radical and written out in front. Now this 3 has nothing to match with it. So again, as before, it's going to stay inside my radical because I cannot simplify it out. And the other important step to remember is that I want to keep the index that was on my radical there, so I know I am still dealing with a cube root. And this right here is my simplified answer for the cube root of 24. It simplifies to 2 cube root 3. Now if we take a look at this third example, 2 cube root 108, let's go through the same process to see how this simplifies. This one's a little different because we're starting with a number in front of that radical already, but what we do to simplify the radical is very much the same. Again, I'm going to use a factor tree to reduce 108 down to its prime factorization, and we see that that simplifies down to 2 times 2 times 3 times 3 times 3. So inside my radical, I have 2 2's, 3 3's. Again, since I'm looking for cube roots, I'm going to look for any factor that occurs 3 times, and I see right here, I have 3 3's. Like I did with this problem over here, when I saw that there were 3 2's, I could simplify that out. In this case, I see 3 3's. That means that factor will come out in front of the radical. Now, there's already a 2 out in front of the radical. That's going to multiply by whatever factor gets simplified out of my radical. So I'm going to have that 2 that was already there multiplied by the factor of 3, which I can simplify out from the radical. And then the 2 that's inside the radical, I only have 2 of them. I can't remove them because there's only 2 of them. I'm looking for cube roots. I only have 2, so they have to stay inside. Now all that's left for me to do to finish out this problem is to multiply together the factors that are next to each other. So the 2 and the 3 that are out in front will multiply together. I will still have an index of 3 on my radical, and the 2 2's that remain inside that radical will stay there, and my resulting answer is 6 cube root 4. This is exactly the same process even if our index is different. For example, if I want to simplify the 4th root of 32, I take the number 32 and I reduce it to its prime factorization. 32 is 2 to the 5th. So I end up with 5 factors of 2. Since I'm looking for a 4th index, I see that I have a set of 4 2's inside my radical. I can take the 4th root of those 4 2's, and they simplify out to a single factor of 2 outside the radical. There is 1 that is left inside, and so that one remains inside my 4th root radical. So the 4th root of 32 is 2 4th root 2. Now, last thing I want to talk about is simplifying a negative cube root. When we're simplifying radicals that are even radicals, we're always talking about the principal square root or the positive square root, but I know that for a cube root, it can have a positive value or a negative value. When I see an expression like the cube root of -4, that can be simplified. I can't reduce down the 4 at all, but I know that the cube root of -4 is the same as the negative cube root of +4, and so we can simplify a negative cube root or a fifth root or any other odd level root by taking that negative sign and bringing it out in front. And this will often allow us to continue simplification and combine that term with other factors that are also cube roots of 4.